Hello class, this is just 3 more examples on trigonometric identities. At any point here you can pause the video and give this a go yourself. So let's get straight to it. So in this particular example, we'd like to work on this left hand side to make it look like the right hand side here. So first we're going to expand the left hand side. For this we square the first, leave some space, we square the last, and we take the product of the two, so sine A cos A, and then we double it. From here, I hope you can see we can bring these two together. You don't have to actually write this down like so, but I'm bringing them together just to really emphasize the next step that we're about to do. Whoops, move this out of the way. And as you can see from here, these two make the Pythagorean identity. So of course you could have just circled them or something to indicate that they're going to become 1. So that becomes 1 plus 2 sine A cos A, and that there is equal to the right hand side. And there we have it. Let's move right along. Now at any point you can pause it and give this a go yourself, but here we go. Now in this step you might want to do the following and make tan in terms of sine and cos. You can go ahead and try that, and then you would have to combine that -1. So I'll take you through the first step here. You might do something like 2 sine squared A over cos squared A. Now since that's -1, you might make it cos squared A over cos squared A, and then combine these two. Actually, I could have made it like so, and then combine these two denominators and then work from there. But just to change it up for you, we're going to work from this one here. Now as you can see, there isn't a tan here, but we have tan squared, in which this one we can make it into tan squared. We can do so by dividing by sine squared for the whole thing. So sine divided by, sorry, I realized not sine, cos. You'll see why in a moment. So now sine squared divided by cos squared becomes tan squared theta. Cos squared divided by cos squared becomes 1. And 1 divided by cos squared is sec squared theta. From here we can rearrange this to become tan squared theta equals sec squared theta minus 1. And it's this identity that we're going to be using for this one. So looking carefully, tan squared is sec squared minus 1. So we could just use that. We could say tan squared A equals sec squared A minus 1. Now I don't write the identity down because I like keeping my my identity list short and just work to find the identities that I need. You could, if you want to, just write down all the identities, but as you can see, I prefer just keeping it really short. So from here we can say, therefore, the left hand side is equal to 2 times sec squared a is 2 sec squared a. 2 times tan a, which is now this, so 2 times -1 is -2, and then we still have that -1 there. Collecting like terms becomes 2 sec squared a minus 3, which is equal to the right hand side. And we're done. One last example. Similar once again to this, we have cos squared theta. We have that here. So we can make cos squared theta on its own by moving sine squared to the other side of that identity. So we can say cos squared theta is equal to 1 minus sine squared theta. So therefore, we can say that the left hand side is equal to 3 times cos squared, but remember cos squared is now going to be this identity. That's going to be 3 times 1, 3 times minus sine squared, so -3 sine squared theta. Oops, and there's a -2 still part of the left hand side. 3 minus 2 is 1 minus 3 sine squared theta. And that there is equal to the right hand side. So I hope that gave you further insight into using trigonometric identities. And as you can see, it's really just this one that we use quite often, and sometimes even the tan identity. So I hope to see you in the next video. Best of luck.